Hi there, my name is AYUSHMAAN Roy. This is the assignment one for Comp 2560. My student number is 110168184. Let's start out with question one. Um, let's GCC compile it. No errors. Then let's echo. TXT, then dot slash question one. So you can see the size is 18 bits. And then so you can see the location. So first we open question one, the file it calls the lseek function with at the fd comma 0 comma seek underscore n. The return value is offset at the end and the file size in a bit. You can see my program matches with the ls minus one size, so it's correct. Let's go to question number two. This is my code. And oh, oh, my bad. This is the wrong writer. Writer.c is writer. GCC compiled dot slash AR writer. This is my text file. You can see this and then QOD. So CR writers dot text. Oh, head. So you can see that. So this question two uses the system I only. I open AR.text and I do write one bracket with the entire text, and this displays three spaces between the first two columns and the tabs between the others. OD's bracket C shows spaces between the semicolons. No, meaning the the quotation the quotation marks, and tabs as the slash t xxt shows the same bits as in the hex, confirming the exact format. Let me just show you the xxt. They are writers dot text head, so you can see it matches up. All good. Now let's move on to question three, an easy one. It's my code. GCC compiled. Let's run it. Let's use writer's text file again. It has two lines. So basically, question three opens up and reads and closes chunks and counts every slash like backslash like new line backslash n basically, and then the total amount is printed in the line count in AR writers.text. Right? That's basically it. Question four. Let's go to question four. This is the code. Now this question four is the same as question three, but it repeats with standard IO. Let's compile it. For compiled, and let's run it. Right. So it does the same thing, but it just changes the standard IO, as you can see. Um, then let's go to the main difference between these two is the the main difference is this function. Okay, a while function. As you can see, this is the size of bit, which is what we did in lab 2, if I'm not wrong. But this is the standard IO, which is completely different. Like it's the one we were taught in the lectures. But yeah, that's basically it. Question four is done. Let's do question five. Same logic, same. It just reads everything. Let's do question five real quick. Here are question 5.c. So this is a code. Let's compile it. Compile. Run it. The same text file, and you can see the current content of the file is 1001, and the GM Birkin 2014. It just shows whatever's in the file, and if I want to add something, let's say 1050 Honda. Oh, it's lagging. Okay, Honda Civic 2026, right? So that's what it looks like. Then let's go to question basic. Okay, wait. To explain this, question five opens the file with the system calls and shows the current content, and then reads my keyboard input from the wherever I am, whatever input, and it seeks with the end of the lseek function, and writes the new text, and finally seeks it back into the start or displays in the updated file. Mm-hmm. And then question six is that exactly, but with the standard IO, which is six question six dots. Oh, what? Cat dot AR Q6. Let's see. What the Q6? Let's see. Oh, there's nothing. Okay. Let me just. So then we're back to the. Let's go back to question number six. Cat AR Q6 .c. This is the code. So so instead of using open bracket, read open bracket, write, close, or unlisted, like in system IO, we use studio and fn open, fgh, like all that. We replaced everything like that. We use printf as well. So let's compile it. Okay, so it's laggy. It's just a little laggy. Okay, question 6, compile. Then let's run it. So let's add this all Ultima, and then as you can see, it changes it up, same as the last question. And then that last but not the least, question number 7, er q7.c. So this is the last file. This is from the from the textbook. So basically, question 7 recreates the textbook file whole with example of standard IO with f open, f write, and f seek. Uh, and let's just run it let's just GCC compile it real quick. It's compiled, and let's run it. Q7 ran, and that's ls -1 arq7s dot text. So you can see the location, and then it shows the logistical size. And then let's do du -h arq7 s dot tx. So 8.0k. And then let's go to od minus c arq7 s dot txt. So then you can see that. So I write 10 bits and jump from 16k beats with fseek, and then write 4 10 more with ls -1 shows logistical size bytes, and but the du shows a much smaller disk usage. The middle bytes and the holes o proven by do/c. And that's basically it. Thank you so much for listening, and this is my submission.